this lesson we're going to be factoring polynomials by grouping. So the definition, there's not, it's less clear, but we're going to just kind of describe the types of polynomials that we're going to be applying this method to. So we'll be sticking with 4-term polynomials, usually of the form ax cubed plus bx squared plus cx plus d. So usually the characteristics are 4 terms, and it's usually going to be cubics here for Algebra 1. We might get into a few that aren't cubic anymore. So some examples: 64x cubed plus 24x squared minus 80x minus 30, or x cubed minus 5x squared plus 5x minus 25. Some non-examples: those two are both not 4 terms, so they are non-examples. So let's play everyone's favorite game. Should I use factoring by grouping? So if we look at the first one, should we use factoring by grouping? No, it's not 4 terms. What about for the second one? Yes, absolutely. It's a 4-term polynomial. Looks just like some of the examples we saw. What about for example number 3? No, that's a binomial. Only 2 terms. Okay, so here are the general steps that we're going to use to factor by grouping. So we're going to kind of go through the steps and apply them to the polynomial 5x cubed plus 25x squared minus 6x minus 30. The first thing is to be put into standard form and group the first 2 and last 2 terms. So for our example, it's already in standard form, so we didn't have to do that. So what does it mean to group the first 2 and last 2 terms? So 5, let me zoom in here, x cubed plus 25x squared minus 6x minus 30. Okay, I'm going to just put parentheses around the first 2 and parentheses around the last 2. So this is very similar to part of the method that we did when factoring trinomials where a is not equal to 1. Now that we've got those grouped together, we're going to look at each group separately. So when we look at this first group, I see 5x cubed and 25x squared. We're going to look to pull out the GCF, so this is step 2, factor out the GCF of each group. So between those 2 terms, they both have 5x squared. And what's left over? X plus 5. Wonderful. When we look at our second group of parentheses, we look at the negative 6x and the negative 30. And since the leading term is negative, we do want to factor out a negative. So negative 6 comes out, and that leaves us with x plus 5. This looks like something we've seen before. So when we see a common binomial in both of those terms, we can factor out that common binomial. So x plus 5 comes out of each term, and we're left with 5x squared minus 6. 5x squared minus 6. And that's our factored expression that is equivalent to 5x cubed plus 25x squared minus 6x minus 30. Wonderful. So let's look at another example. So here we've got 4x cubed minus 7x squared plus 28x minus 49. Once again, we're going to group the first 2 terms and the last 2 terms. We're going to look for a common factor in the first group. No coefficient common factor, but they both have an x squared. So that's going to leave us with 4x minus 7. Great. And from the last 2 terms, they both have 7 as a common factor, and that leaves 4x minus 7. So we see 4x minus 7 in both terms, so 4x minus 7 comes out, and we're left with x squared plus 7. And so this is the factored form of the original polynomial. Let's look at an additional example that does kind of reveal that there sometimes is an additional step at the beginning. So let's go to an example like number 32 here. Oh my, didn't those numbers get so much bigger? So when we look at 32, there's really some work we can do right off the bat that would make this a lot nicer. So if we see a polynomial and the numbers are larger, we should look at the terms and see, is there any greatest common factor to all of them? Way back in the beginning of this unit, that's what we first did. We looked at an expression and we pulled out the GCF first. So I'm looking at the 4 terms, and the last term has no a's in it. So there's no variable GCF. But if I look at the coefficients, I might apply one of my favorite factor rules is, does it divide by 3 by adding the digits? So this adds up to 6, this adds up to 12, this adds up to 6, and this adds up to 12. So the entire thing, all 4 factors are divisible by 3. So I can pull out a 3, and that's going to be 3 times 35a cubed. So 3 goes into 8 2 times, and then 3 goes into 24 8 times, so 28a squared. 3 goes into 60 20 times, so 20a, plus 3 goes into 48 16 times. Great. So now that we pull out that GCF, it's at least a little bit more manageable for us to proceed. So the 3 is going to kind of carry along here for the whole journey. I'm going to switch colors here, and we're going to group the first 2 and the last 2. Okay, so between the first 2 terms, I see 7a squared that can go into both. And that leaves us with 5a plus 4. Great. From our last 2 terms, we can pull out a factor of 4. And that leaves us with 5a plus 4. Oh, great. I'm so glad we got the same thing both times. That means we're doing something right. The 3 comes down along for the ride again. And then we can group our 7a squared and our 4. 7a squared plus 4. That's our one term. And then the other term is our 5a plus 4. Great. So that's an example of when there was a GCF for all 4 terms. We pulled that out first, and then we proceeded as normal. Let's just look at one more example like that, since that's a little bit more advanced. For this one, if we look at all 4 terms, we do notice that they all have a variable term. So we can definitely pull out an x. Is there any numbers that can go into all of them? So I right away see 9 and 15, so I'm thinking, oh, maybe 3 again. So 7 and 2 is 9, 1 and 2 is 3, that's 9, and that's 6. So yes, 3 goes in again. So 3x goes into all of them. Let's go ahead and factor that. So 3 goes into 72 24 times. So 24, we take away 1x, so 24x cubed, plus 40x squared minus 3x minus 5. Now, if at this point we didn't pull out the GCF, if there was still a greatest common factor, we could look amongst these remaining terms to check to see if there is. So if I look at the coefficients, I see a 5 here. Its only factors are 1 and 5, and 5 does not go into 24 or into 3. So there's no coefficient GCF, and the variables, 5 doesn't have a variable, so yes, we did find the GCF. It is already taken care of. Okay, so we'll group the first 2. We'll group the last 2, and we'll bring down our 3x for the ride. We look at 24x cubed and 40x squared. They both have a common factor of 8x squared, and that leaves us with 3x plus 5. And then this is a little sneaky. Yes, there's no significant factor, I suppose, but they both have a -1 that can come out of it. And I know that -1 is going to be important here to pull out because I want this to be 3x plus 5, and we have 3x minus 5. So I have to pull out a -1 to give me 3x plus 5 into both of those. So then the 3x comes down again. We have 8x squared minus 1 and 3x plus 5. And that is the completely factored form of our original polynomial. So thanks so much for joining us for Factoring by Grouping. Hope to see you guys again soon.